Welcome to part 2 of 9.5 videos. Hey, I'm going to get going on this one because, as you can see, number 4 looks like kind of a monster problem. So, recapping from what we did in part 1, got to determine the restrictions first. So we have an x minus 1 on the bottom of this guy, number 3. Well, if I stick a 1 in there, 1 minus 1 is 0. Can't have that. Step 2 is to solve the problem as if it were an equation. Now, I'm going to put a 1 underneath there. Because if I'm going to have common denominators, that guy's got to have a denominator as well. So for starters, let's go with this. If I put a 6 on the bottom of that guy, and I put a 6 on the bottom of that guy, they all have 6s. So I'm a little closer to being what would be called common denominators. The guy clear on the right has the 6 already. But you know what? He doesn't have a binomial of x minus 1. But he does now. Same thing on top before you forget. So the second denominator and the third denominator are common. They both have a 6. They both have an x minus 1. What's the first one missing? I see a 6. I don't see an x minus 1. So this one definitely more involved than the problems we did in part 1 video. Cleanup time. First fraction has an x minus 1 times a 6 times a 1. I'm going to go ahead and distribute that out. So that is just me taking the 6 and distributing, and times 1 really isn't going to change anything. The middle fraction now has a 5 times 6, which is 30. We can treat these guys like equal to problems, equations. I don't need that less than symbol necessarily, although it wouldn't hurt to put it there. And I'm going to distribute out that last one as well. So 7 times x, 7 times 1. So that's just me doing the distributive property right there. And then it's just a matter of solving this guy. So my 6x, okay, I got a plus 30 and a minus 6. I'm going to put those together down to this. I need to get the x's on one side. I'm going to move that 6x over. And last but not least, I got to add 7 to both sides, and I got it. So let me box these guys in so we can see it. There's our answer. There was our restriction. And now we got to do a number line. All right, number line. I've got a 1 for my restriction. I got a 31. And so here's I don't know if this is a tricky part, just a hard part to remember to do. So to figure out where the answers are, which ones are true, which ones are falses, we just go ahead and plug a number in. So this time, I'm going to plug 0 in. So 0 is clear down here, obviously to the left of 1, but he's the easiest number to plug in. So up here in the left corner, going to do it again like I did in the last video. So I'm testing. Original problem had a 1. It had 5 over x minus 1. I'm plugging a 0 in. And that was the only place to plug a number in. So I got 1 plus 5 over negative 1 less than 7, 6. So that's 1 plus negative 5. So still trying to determine if this is true or false. That's negative 4. True or false is a negative less than or equal to a positive, and that's true. So we've got a lot of true for answers on my example so far, so don't assume it's always true. It could be false as well. So here's where I tested that number. He was true. For our purposes, they're going to go back and forth, and that next one's going to be true, or that middle one's going to be false, and that end one's going to be true. So if I go ahead and shade, which I think is a really good idea, and you're going to see why. Okay, now where did I get the 31? I got it from solving the problem, and the original problem had it less than or equal to, so that's why I get the closed circle. This guy's got to get an open circle. Why? Think about that for a second. What did we say about x and 1 in the first place? So restrictions are non-equal to. You can't use restrictions, and if I can't use them, I hope it makes sense to you. Oops, I'm shading the wrong spot. I hope it makes sense that you would use an open circle for restrictions. So we always use open circles for restrictions. And I'm shading where the true answers are, not the false answers, duh. And then I'm going to go with interval notation. So my answers go from negative infinity all the way up to 1, union the other part of the answer. Now I'm using a bracket this time because the 31's got a closed circle. on to the right forever. It's a terrible infinity sign. I hope you can figure that. That's what that is. So there's the answer to that guy. All right, problem 2. Little tougher. Hey, when in doubt, factor it out. So I'm going to do a little factoring right here. X minus 3, x plus 3. And it helps for several reasons. I can determine my restrictions. So I know that x can't be 3. And I know that x can't be negative 3. So plus minus symbol there if you wanted to. All right, common denominators for this one. A little tougher. So I'm going to deal with this last fraction first. So notice the first one says x minus 3. But the last one says 3 minus x. Well, it's not quite the same. What would happen if I multiplied that guy by negative 1? You'd flip them around. All right, so I'm going to move this up, give myself a little bit more room, and I'm going to rewrite this. So now I have x over x minus 3, x plus 3. Middle one I haven't messed with yet. Treat it like an equal problem now. So I'm going to go ahead and multiply that out. I'm multiplying the top by negative 1. I'm multiplying the bottom by negative 1. I multiply that bottom one by negative 1. It's going to flip it around, and that's helping me out. All right, now common denominators. I'm going to switch colors. So the first one has a pair of parentheses, but the second one only has 1. Well, I put an x minus 3 there. They match now. The guy on the end has an x minus 3, but he doesn't have an x plus 3. But he does now. All righty, let's clean this up. Denominators are common. I don't need them anymore. First fraction had an x. The second one, I'm going to distribute. I got 4x minus 12. The third one, I'm going to distribute. I got 5x plus 15. Clean it up. This side, I got 5x minus 12. This side, I got 5x plus 15. Guess what happens to the 5x's if I subtract them from both sides? That's right, they cancel. So this is a crazy one. What's left? It's important. I got a negative 12, and I got a positive 15. So way, way back, we determined that that would make a no solution if the x falls out of this guy. But here's what makes this one crazy. You still have to make a number line if there were restrictions. The directions did say make a number line with the restrictions and the answers. So just because there aren't any answers doesn't mean I don't make a number line. So number line with 3 and negative 3. Test a number. I'm going to test 0, guys. All right, now this is going to be tough to squeeze in here. Let's see what I can do. So if I put a 0 in for this fraction, it would make it 0. If I put a 0 in for the second fraction, it would make it 4 over 0 plus 3 or 3. Greater than or equal to. If I put a 0 into the second fraction, it would be negative 5 over 3. So 3 minus 0. So true or false? Oh, gee, this one's going to end up being true again. I promise you, they don't always end up being true. So is positive 4/3 bigger than negative 5/3? Yes, a positive is bigger than a negative. So down here on my number line, true, false. Oops, false. I like to put my falses below the number line, my trues above. No particular reason. Shade where the true answers are. Restrictions always get open circles. No brackets, so I'm using parentheses. Where's my shade start? Where's my shade end? So there's the interval notation for that one. So that one was a little tricky, a little crazy. The fact that I ended up with no answers right here, right? It's a false statement, no answers, doesn't mean I don't get to make a solution set. So you still have to test the number line. You still have to put the restrictions on there. And once tested, you find out that the answers fall between negative 3 and positive 3. Thanks for watching part 2. Stay tuned for part 3. Part 3 has some cross multiply problems, a little bit different. You might want to check those out. Thanks for watching.